Welcome to our Build 2020 session on evaluating and optimizing your costs using the Microsoft Azure well-architected framework. I'm Jason Roberts from the Patterns and Practices team, and I'd like to introduce you to your speakers, Abdul Sheikh, a program manager in the Patterns and Practices team with developer relations, and Alex Agudelo, who is a global Azure engineer with the Customer Success Engineering team.
Thank you, Jason. I'm super excited about the announcements so far at Build. Project Cortex, Microsoft Graph, Fluid Framework. I think GitHub Codespaces is a game changer. What do you folks think? Let us know. We'd like to hear from you. On to the agenda for today's session. Lifecycle cost of enterprise solutions are a primary focus of our customers. One of our key goals is to enable architects and developers deliver consistent business outcomes with predictable cost. We want to help ensure you stay within your allocated budget and drive positive return on investment for your enterprise workloads. In this session, you will get a perspective of how cost, along with 4 additional considerations, will lead to a well-architected solution. The Microsoft Azure well-architected framework provides guidance and architectural best practices curated for developers, architects, and solution owners to improve the quality of your workload based on 5 pillars. The 5 pillars of Microsoft Azure well-architected framework are cost optimization, operational excellence, performance efficiency, reliability, and security. These pillars of well-architected are interdependent. Altering one will have an impact on one or more of the other pillars. Achieving a balance between these constraints should be an ongoing effort, both during building your workloads and while operating your solution. For resources that are already deployed, Azure Advisor recommends improvement actions. Having visibility to your organization's advisor recommendations are useful when the workload you're envisioning will be deployed into a common environment like a landing zone. Most landing zones have application monitoring infrastructure, identity, and the security posture that your enterprise has laid out already provided for you. And these are requirements your workload may have to adhere to. The guidance and best practices recommendations of the well-architected framework are part of Microsoft Docs. Let me do a quick demo of what we are discussing. Here is the overview of the Microsoft Azure well-architected framework. Here are the 5 pillars again. Note that the content is organized by principles, design, provision, monitor, optimize, and trade-off sections. We intend to follow a similar strategy across all the pillars. Please provide us your feedback on this approach. My team has published in the Azure Architecture Center and GitHub a reference implementation of the microservices architecture using the Azure Kubernetes service. We will use that architecture as an example for this review. In this architecture, we will focus on the cluster cost and the backend Cosmos DB database for cost modeling. You can begin an assessment review directly from here. This assessment review will help you quickly evaluate your workload to pinpoint opportunities for optimization. You have an option of signing in and persisting your reviews for capturing progression of your workload characteristics over time. I'm already signed in, and I will choose just cost for this demo, but you can select multiple pillars for your review simultaneously. For the questions in the assessment, please answer them as fully as you can. These questions cover the principles that are important to your architecture, your design considerations, and the trade-offs you've made. There are additional questions on how you plan to provision, monitor, and optimize your solution costs over time. Ensure that your answers are specific to the workload principles and not that of your entire organization. Click through to complete the assessment. Here are the summary recommendations of your assessment. This provides customized guidance on next steps and actions to improve your results. Your opportunity for optimization is represented in three ranges of critical, moderate, and excellent, in addition to a numerical scale. Let's look at a specific recommendation. This recommendation is about cost modeling. We would leverage the Azure pricing calculator to model your solution cost for the example AKS reference implementation. Our objective is to take into account the total cost of ownership and the cost of building and operating your solution over time. Remember to include network ingress and egress costs, which are often overlooked in your pricing estimates. In the pricing calculator, we look at estimating AKS cluster node VM sizing. Note that there are no charges for cluster management. However, there is a charge for uptime SLA per cluster. The instance VM costs are available in the pricing calculator. We are choosing a 16 CPU 64 GB RAM VM. By taking the approach of reserving an instance either over a year or a 3-year period, you have the opportunity to save up to 62% in the instance costs. We look at the Cosmos DB cost options. In our reference architecture, we have the option of a single region or a multi-region implementation. We will choose multi-region, and again, by choosing your reserved instances, you have the ability to save significantly on the cost of your Cosmos DB. One of the inputs to the Cosmos DB cost calculation is your throughput request units. I'm going to use the Cosmos DB capacity calculator to estimate more accurately the throughput request unit that would be applicable for our reference workload that we are cost modeling for. We have chosen here a SQL API with 2-region and enable multi-region. We will choose eventual consistency. The choice that we are making here, which has the most significance on the cost, is that we would have 2 terabytes of data per workload per region. We are also estimating the percentage of peak time characteristics and indicating that the workload mode is variable and will have a 10% peak traffic throughout the lifecycle. You can also specify item size. By selecting appropriate choice for your read and writes, both at peak and off peak, you arrive at an estimate of 20,000 throughput request unit. We take this and plug this back into our cost calculator to do our cost modeling. You can perform a what-if analysis of your total solution costs in this manner. Reevaluate your cost by including bandwidth compression, reducing chattiness, and avoiding extraneous fetching. Use these cost parameters as a starting point for your application throttling metrics. We will switch back to the slides and review what we did in this demo. Summarizing, we started with the AKS reference architecture and reference implementation. We did a well-architected assessment, and based on the recommendations, we performed a cost modeling exercise. Based on your analysis, you could establish a lower bound and a higher bound for your cost, and you could use that to set cost alerts for your workload. Alex will go through here in greater detail the notion of choosing right and a decision tree for compute and other technology choices. Over to you, Alex.
Great. Thanks a lot, Abdul. Wow, I tell you, I wish I had some of these tools and some of these assessments a couple of years ago when me and my team were working on this, but that's for another time. So this slide here is basically showing you some learnings that we kind of gathered internally here, and we've put it into a document so that you can reference and leverage. And so this is really a guideline to help you choose the right service and the right infrastructure for your workload at the right time. And so basically, there are many different paths to getting to your final destination. But, maybe you don't necessarily need to have a particular service or a particular infrastructure to develop and to write your application so that it's performing at its peak performance, that you have all the resiliency in place, and that you can build it at a fraction of the cost, right? And so what I ask and what I encourage all of you to do is, as you're going through your development journey, is to really ask yourself the hard question. and that is, do I really depend on this particular VM or this particular service? Is there an alternate path that will provide me with the same capability, the same performance at a fraction of the cost? And so this decision tree is designed to assist you with that. It's kind of like a starting principle, if you will. And we leveraged it, and it's really quite when you start to go through it, it really helps you kind of think clearly and think of all the different possibilities that exist out there. So we've documented this. This is in the document library along with all the other tools and assessment that Abdul just shared with you. And if there's one thing that I hope that you get out of this is that, not all scenarios are going to necessarily require an IaaS layer or a VM. There are many such applications and scenarios that you can move directly into a FaaS solution or a function, or even go serverless. Ultimately, where you're going to get the best performance and the best optimized state for your application is in a serverless environment. So I encourage you to leverage this document along with all the tools and documents that we just shared with you previously. And we thank you for your time this morning or this afternoon, wherever you're located. Thank you for being with us. So we wanted to be able to have enough time for Q&A. And so with that, I think, Jason, why don't you, do you think it would be a good time now for us to kind of go over some questions?
Yeah, definitely. We're getting a couple of questions rolling in. We've got a few questions about that assessment tool. Is the assessment tool that was shown in the demo generally available?
It is generally available. We have still a private, like a preview tag on it. We are working on completing some aspects of this tool. We have some future roadmap for that. And our goal is to get feedback on this by making it available to everybody right now. And based on your feedback, we would add some additional capabilities to the tool.
Awesome. A couple of people are asking, they're trying to find trade-offs information on specific architectures. An example here about hosting their spas within a storage account, static website versus using an app service instance or some other Azure resource. How does someone go about answering questions like that for themselves?
So I'll take that. The trade-off question, our assessment is kind of designed to answer that. That is one of our goals, is that when a customer in Azure wants to have a formal structural way of thinking through these trade-offs, they would come to this well-architected framework assessment. That is the goal. And I also mentioned during the demo that for each of the pillars, we are going to talk about trade-offs. What are the cost trade-offs and how that affects other pillars? And what are the security trade-offs and how that affects cost and performance? So, this body of knowledge, as well as this assessment framework, will be your place to go for answering such questions. Alex, you had something to add to that as well.
No, you're spot on, Abdul, and as well, all of the documents that we shared, including the choosing right. It's not going to show you necessarily the trade-offs, but at least it'll start to have you think about, okay, this is kind of where I'm thinking. Now I'm going to go back to the tools and the assessments that Abdul was sharing, and then you can reconcile a lot of those decision trade-off that you need to take. So.
All right, thank you. We have a few questions on optimization choices. One on region of resource. How does the region affect costs? And if an app server is in one hemisphere, are there any effects on cost or performance or any other considerations that need to be made?
So you want to take that, Alex?
Absolutely, yeah. So so there are a little bit of a cost trade-off. Obviously, if you have an application that requires a global footprint or global redundancy, things like that, that's more of a premium type of service. And so yeah, premium obviously, as it's stated, is a higher cost. Whereas if you go more to a standard type of service and or local or regional, you're going to get a better cost performance, if you will. And so, back to Abdul's earlier point, those are the considerations that you need to weigh and kind of balance, right? Is my application going to be an application that needs to be a global? Do I need to have redundancy, across all these different regions? If yes, okay, great. Understand where your costs are coming from with that. But if it's not required, and if you can maybe adjust that a little bit, and your target audience, if you will, is within a region, you're going to get some better cost performance that way as well. So those are all part of where you balance and where you can kind of look and pick and choose tiers and the different options that are available for you. Yep.
The cost calculator is a good place to determine those. You can actually set the region in which your workloads are going to be on to determine the cost. The other thing I mentioned briefly during the demo is when you have these regional workloads, make sure you think about the network cost, the egress and the ingress. That is something is typically overlooked, and that adds to your cost eventually. And depending on the workload and the number of data flowing in and out, that could be a significant cost as well.
Yeah.
I believe this is probably related to the reference implementation from the demo, but can you deploy a reference implementation with an ARM template?
Yep. All our assets are available as documented in our Azure Architecture Center. Underlying that, you will have links to our GitHub repo. It is github/mspnp. And under the github/mspnp, there are about 30 repositories. It's almost one repo per reference architecture. We used to have all the reference architectures in one repo, and we felt that the customers are having difficulty getting the ones that they need. So we are splitting them up. So yeah, you can have deployable assets. These are all open source, and you can actually contribute to that as well. Let's say you are figuring something out and you deploy this, you find something that is not working, or you find something that you want an additional information on, please provide GitHub issues to us. And we look at that on a weekly basis and we respond. And our goal is to get these fixes out to you as soon as we can.
Excellent. We have a few questions about the pricing calculator. One in particular, can you tell me more about the pricing calculator and if it will be updated to reflect architectural guidance when speccing out new projects or solutions?
So the pricing calculator, I don't think mapping that back to architectural guidance is in that roadmap. The pricing calculator is essentially you have your architecture, and then here are the components of your architecture, and then you take the components of your architecture and you plug it into the pricing calculator. That's one of the reasons why I picked this reference architecture, as though something that has been envisioned, and most enterprise organizations would come up with, here is the template of what I want to do and all of that. And then you take those components and you plug it into the pricing calculator. The architectural choices of whether I should go one way or other are determined in your assessments as part of the well-architected framework and through the decision trees that the choosing right decision trees that Alex referred to.
Excellent. Can you speak a little bit about the shared responsibility model? In particular, there are some questions about is the shared responsibility model available on a per service basis? Is it global to Azure? There are some discussions on high level general breakdowns, although there may be some text indicating that it varies on a per service basis. So yeah, can you just talk a little bit about shared responsibility for us?
It's a broad topic. I mean, one example of a shared responsibility is if you're using IaaS servers, patching is your responsibility, whereas keeping the VMs up and running is Microsoft's responsibility. However, if you are using, let's say, a function app, there is no patching necessary, and a lot of that responsibility kind of falls on Microsoft to keep your need for that function. When you have the event, we provide the compute associated with that. So that's kind of the range of shared responsibility. The other area where shared responsibility comes quite a bit is on the security space. The shared responsibility of security space is that in the VNet, in the network infrastructure, and all of those structural parts of your architecture, Microsoft responsibility is about security. But you as an application owner may want to have a firewall turned on. You may want to have a DDoS protection turned on in your ingress controllers. You may have load balancing available so that your workload characteristics are not impacted. So that is the shared responsibility in that space. So to look at shared responsibility, you can look at it from different facets, and I think I covered a couple of them, but it's a quite a broad question to answer within this time that we have.
All right, we've got some interest in that choose right flowchart. Is that guidance that's relevant for new workloads? Is it also relevant for refactoring scenarios, legacy systems? How do we know when the appropriate case is to go and reference and look at that?
Yeah, I can take that. That's an excellent question. Absolutely, it is designed to not only for new workloads, but also for refactoring as well. I kind of mentioned a little bit about, the direct benefits or the direct impacts when you're selecting a particular service or infrastructure. There are so many indirect benefits to a lot of the selections as well. And so you definitely, so one of the things that we used to leverage the decision tree for was definitely to refactor a lot of legacy systems and applications and services. And so, maybe at the time we designed an LOB app or a service, and it required a VM and it required an IaaS infrastructure, and that was really good for that time. But one of the great things that at least me and my team did, we would go back and every so often, maybe on a quarterly basis, we would review, okay, is it still relevant to have this infrastructure in place? Is there a new service that's out there? Is there a better way of performing this particular application today? And so we'd constantly be reviewing that, and then we go through the decision tree, and that would help us say, oh yeah, we used to have this in an IaaS layer, but really, we can perform much better, have better performance and at a fraction of the cost if we were to move this into the PaaS layer or even into a function and ultimately to serverless. And I know I kind of mentioned that before, and Abdul was kind of alluding to it in just the previous question, but really I highly encourage folks, if you haven't really checked out the functions as a service or even going serverless, that's ultimately where you want to go, because that's where you're going to get the best bang for your buck. That's where you can get the most performance, the most resiliency, and you're only paying for the compute time that you're actually utilizing. So I encourage you to check that out.
To build on that, I'm generalizing a few questions here, but for the assessment tool for the well-architected assessments, is that also appropriate to use on production workloads, or is that better used during the design stage?
I think the tool is applicable for both. For production workloads, what you will get is advisor recommendations, like I mentioned in the demo. But what you won't get is the what if part of it. What if I change some of these aspects, right? And you would use, even for a production workload, the assessments to go look at your other options. If I take this component and modify it, what are my performance implications? What are my cost implications? You will have that frame for an existing workload. And it is obviously something that you can use for a workload that you're envisioning as well. But like I mentioned, even for workloads that you're envisioning, they would eventually go into a centralized infrastructure that your organization has provided. So be cognizant of your advisor recommendations for those and what are your organization's policies and principles are. So that's, I think it works for both. Short answer to that.
Yep, definitely.
All right, excellent. Can you speak a little bit more about how, in the process of migrating an app to PaaS or serverless, your costs would be reduced? the aspects of consideration there?
Yeah, let me start with that. So, one of the things, if you're working in the IaaS layer, you're purchasing a VM, you're purchasing all this infrastructure. That infrastructure, I mean, you own it, and so it's turned on 24 hours a day, 7 days a week, and so that clock just keeps ticking, and you just keep paying for that service. On top of that, there's all this indirect impact, and that's the maintenance, the operations, the security that you have to patch it, and et cetera, et cetera. You don't want to really do that, Whereas if you were to move your functions and your applications into a PaaS layer, or maybe into the functions, or even go to serverless, you're only paying for the compute time that application is actually running. And so when there's an activity, great, it bursts, it adjusts, and it provides that support and that capability, and it performs, and that's what you pay for. Whenever there's downtime, you don't need to necessarily pay for that. And so there's lots of scenarios where going serverless or going into a function is far much more beneficial than just staying in the IaaS layer. I can think of several instances. One in particular would be like if you had a print service inside one of your companies or something like that. The printing service doesn't run in the middle of the night, as an example, right? And so when no one's in the office and no one's printing, what happens to those servers, right? They keep ticking, and they're still on, and so you're still paying for that. Whereas if you were to move that into a PaaS service, migrate that over into a function or even into a serverless, when there is activity, well, then you're actually paying for that compute time. So those are things that you need to consider and to balance and to weigh. So really make sure that you're getting the right service, the right infrastructure for your workload at the right time. Yep.
All right, excellent. So as this session is about evaluating and optimizing costs, there's a question here that I think is kind of squarely in the middle of it. So I'm going to make sure we get to this one. And this is probably about broadly the relationship between budgets, calculators, estimations, billing, et cetera. Is a budget linked back to the details of a calculator estimate? Can it provide that level of traceability? How do you relate all of those parts together to make sure that as you're delivering your solution, you kind of are hitting the targets that you set out to as you were designing?
So the budget that you would establish in your Azure environment is not directly linked back to a cost calculation estimate that you've made. The cost calculate estimation will give you the lower bounds and the upper bounds, and this will give you a good starting point for what your budget should be and where you should set your alerts to be. And once you have set up your budget and your alerts, the cost calculator is decoupled, right? Because as you consume in the cost calculator, for example, in the AKS, we went and did a calculation of what the throughput request units should be. Instead of 20,000, your actual workload may only be 10,000. And so in order for us to be able to tie these two things together, it's very difficult. And so they are essentially decoupled. But the point here is that if your throughput request units happens to be 30,000 and you're consuming cost on Cosmos DB much faster than you expected, then your alerts would fire, and then you will be able to respond accordingly.